Hey everyone, I'm David Room. I thought I'd do something a little different today and uh, do a stream in the morning. So I've been wanting to try this for a while, especially since I've recently had a lot of growth in my channel, and most of the time when I stream it's at night, and thought it would be good to try experimenting with streaming in some different time slots just to see what happens. And I usually start my day job at about 10 a.m. Central, so there's a good chunk of time there, between 8 and 9 or 9:30 when I could do some quick work and see if I get a new and different audience. So let's get into it. I started working last night on some stuff that I mentioned on the stream that I did last night, building out some utilities for 3D printing. And I'm going to continue that here. So just a quick explanation. You've seen this workflow that I have for programmatically modeling things using Python code. Basically, I have all of these spaceship models that I am building for my game. Here's the ship viewer in the game, and actually going to be looking at this ship just for starters today. This model is created with Python code, a combination of things that I've written with my own code and bits and pieces from trimesh, the numpy libraries kind of underneath everything. And then there's also what I call a high detail version of things. So I have also programmatically created versions of these ships that have extra detail that would be used more in visual effects or other settings. And in this case, I'm kind of looking into using these for making 3D printed toys or statues or whatever of my ships, right? So what I'm working on building out right now is a script that can load in a ship, and loading it in with certain special attributes like the positions of weapons and hard points and different things on it that are derived from the game data. Build a model that we can kind of work with and do different tests on, and then save that to files that are ready for 3D printing. And I've been working on this before, but I'm kind of changing how I did things. So I have this weird kind of round trip between different mesh scene formats that I'm doing, that I'm trying to change a little bit. So I'm working with data that's maybe more sensible. The way this works right now is I'm loading in, this is kind of a wrapped version of something that's loading the model in from disk. That's why it comes up right away when I run this. You can see there's kind of a flash of loading in the console, and then it's there. It's not actually generating this in real time. And then I'm converting from the format that this is in, which kind of represents a model hierarchy for the game. I'm converting that back to the good old parts format that we usually use on streams when we're doing 3D modeling. So parts is kind of my own 3D mesh format that uses a dictionary. So, and I was doing some filtering of different parts and things in this other format, but I want to do it in the parts format, so that's kind of what I'm working towards right now. Something that I've got to do here is clean up some of the printouts and logging. Because I'm also kind of in the middle of reworking how that works. So let's just swap this around, and I've gotta get a logger going here. Actually, what's it called? I wrote this logging stuff a little while ago and I forget. Okay, it's just logging setup. Okay. Let's just see if this runs. And I don't need this flatten config thing anymore. The nice thing about parts, the format, is it's in a dictionary, so it's flat, which makes it very easy to work with. This other format where I'm loading things back in kind of through the format of the game is a hierarchy, so it's a little harder to process. I have all these goofy functions for flattening and filtering and things when I've done so much work with parts as a format now. If I can get it into the parts format, everything is very easy to work with. Yeah, and you can see the coordinate systems on everything here. Okay, so I'm just gonna go ahead and delete all this because we don't need it anymore. So yeah, and loading this in, it's going to have this prefix, which we can still use. We don't really need find anymore. So we can just basically just remove these directly. Let's see here. There's a couple of pieces of functionality that I need to build for parts where I need to be able to grab a subpart of the hierarchy into its own part set with that part as the root. So that might be something that we build out today. We'll see. It's going to be a pretty quick stream. I want to get into my day job here at about 9:30 Central, but we'll see how far we can get. And now we can actually just delete these from parts like this. It's a lot simpler. And let's see here. So let's try building this. Oh, actually, this is perfect. This is perfect. So I already have functionality that does this. If I set parent of this to 0. Ah, jeez, I can't type. It's too early. Then I can group by roots. And I should get these separate. And let's just see. I don't need this Blender view anymore. Revise this name here in just a second. But basically what we're trying to do here is separate out our model hierarchy into multiple if nothing? No. Into multiple hierarchies. Oh, there we go. Multiple hierarchies where each one is going to be like a separate item that's going to be printed on the tray. Oh, that's just a list. Okay. So the obvious thing that I have to do is I have to take the weapons off. Yeah, okay, that's kind of what I expected. And I don't even actually need to group by roots. I can actually just, after separating those, I can... Yeah, see, I added all this functionality to parts to handle multiple roots that I kind of keep forgetting about. Yeah, see, so there's my 3 separate parts, and if I let's see, this should be a dictionary where they, well, just make a quick dictionary version of this guy. I want a dictionary because I want to work with those part sets by name. Just separately. Roots. And this is just a simple... Oh shucks, yeah, that isn't simple because I'm losing the name. Okay. Well, we're gonna have a to-do of rewriting this in terms of this one. Yeah, look at that. Why am I turning that into a list? I just want this. I'm sure I had some reason for this. because that's the name. And I set it when parent is none, so that should be what I want. That's weird. Stop items. Sound values. Okay. State. Okay. So that's our yeah, so let's see now if we have the proper names for things, because that's what matters. Whoops. So this is red 1. That's red 1, weapon 1. And that's red 1, weapon 0. Yeah, so that is working. Okay. So, what we want to do now is start doing some tests on these. Actually, let's just get our current export stuff working again. So, yeah, this is so here instead of all of this crap, we can just do flatten parts mesh V, and that already does that. And let's see if this works. Yeah. So this generates our files for printing. They look pretty bad in the previewer, but what's going on? Oh. Let me just delete this stuff. We can start over. There might be some naming issues, but it's not a big deal. Stuff. And you know what? Yeah, see all this just gets so much easier in parts format. I can strip that name off the beginning. So I can just do this. Okay, 0, actually just fix. Because I believe all of the parts should have that prefix. Yeah. Literally all of them have that prefix, so we can just strip it off. Sometimes you just wonder why you didn't do something before. Part of the fun of doing stuff like this yourself, though, is kind of going through the iterations of how you've built the different data structures, and it's kind of fun in its own way. So this isn't extracting so much as separating the weapons. Oh, I can't just do this. There's a function that I have. Oops. It's on the wrong playlist. Okay. Repent parts. Add prefix. Add suffix. Oh, interesting. I don't have like a remove prefix. That's okay. We just have to do this to the parents too. Because everything is going to have the same prefix. Whew. That did not work. What happened there? Oh. Jeez. There we go. LuxCore Studio says, morning, sir. Hello. Yeah. There we go. And I think what we can actually do here, because there's a single empty. We don't want to get LuxCore Studio says, brave of you to code live. If I did, there would be so much dead air every time I found a bug. Yeah, I like coding live. It's a little nerve-wracking, but it's a good way to push yourself. And in my... Whoops. Oh, that's funny. It's not what I was expecting to happen. In my current job, I don't get to do much pair programming, so I kind of miss it. Now let's see here. Why did that? Oh, I bet I know why. I think we just have to, let me see, how do we deal with this? I think before we do this, I think we just have to rename something. So let's see here. And I would encourage anyone to try to code live if it's something that you're interested in doing. Oh no, it should be fine. Oh no, yeah, we do need to change it because yeah, okay, that is one thing that we're gonna have to change. Do I have a for renaming the root? I don't think so. Yeah. Okay. So maybe we'll just call it root. And parts if parts dot name ship ID, then parent equals root name, and then we're just going to grab the root object out. It's ID delete it and put it back in. Put it back in. Start rip. And then we just have to do this a little bit more subtly, right? Because is there a simpler way I can do this? Because I only want to strip that prefix if it actually does start with it. Oh, I know what, yeah, duh. Because everything except that first part should have this prefix. This is ending up being a stream of just kind of swizzling things around. I was hoping to get into some actual 3D mesh processing, but that might have to wait for another time. What is going on now? So we're ending up with a part somewhere that has an empty parent name. Probably somewhere in this process. So let's just say, yeah. Let's see. Oh, okay, it's the shield. And yeah, okay, that makes sense, because that thing is not, it's not going to be, it's going to have that original part as its prefix. So now let's see, why didn't that get fixed here? Nice. LuxCore Studio says, I approve of the choice of coding music. Sounds like my playlist. Yeah, it's White Bat Audio. He has a bunch of really nice royalty-free music. Let's see. What was the original parent? I'm just forgetting something about how. Oh, yeah. Okay. That's because I've already fixed these. So yeah, I just need to add my... This is fine, because I always want to... We can assume that everything has this prefix, but we can't assume that all the parents have this prefix. So if part.parent is not none and part.parent.starts with prefix, then we strip it. There we go. Okay, cool. And let's just delete these guys again, and we should be saving things out without the red one prefix anymore, because the red one prefix should just be gone. Yeah, okay, good. All right, let's see in the 10 minutes we have left if we can get into a little bit of actual more interesting mesh processing stuff. So now that we have this nice list of like the different parts, and each of these things in this dictionary is going to be a thing that we're going to print, I want to make sure that everything in each of these is watertight. So we don't really need them to be watertight to print them, but before we print, I need a step where I build connections and make modifications to the parts, and to do those Boolean operations, they need to be watertight, manifold, you know, satisfy certain constraints. So let's get into that. Watertight. So I was working on this. I was working on this on a stream. Yeah. Where where it's kind of, I built something out that does some better information about why things aren't watertight. And I kind of want to get rid of this extra check, because I'm checking if things are watertight. And then if it's not, I'm sort of doing this quick processing on it, and I kind of want a version that just doesn't do that. Oh, I just have that. That's called is watertight. It's watertight. That's what I want. And I'm probably using that a few different places. Yeah. Okay, so let's check if all of these parts are watertight. And we can actually do that here. Okay. Oh, hey Jersey. So Jersey says, I read Monty Python coding. Yep, that's about right. That's about how well it's going this morning, but that's okay. Good to see you. Okay. Let me actually... It's possible that actually all of these are watertight. I can bring up another ship where I know that there are going to be some parts that aren't. Nice. Okay. So let's load up a ship where things are not watertight. Gonna get rid of this. Because what we want to start doing is start debugging, working towards debugging things so that that things are yeah. Okay, so that one is not watertight. Okay. And interesting. So I don't know if we're actually getting any info from watertight. See, this is what I need to work through, because I think okay, so that is, I need to actually print that. Okay. And I think there's a few issues that we can have where okay. Okay, so this one might be easy fix. It has two holes in it. So that, yeah, see, each of these should not have more than one. I thought maybe the problem with this, because I've known that this, it's like a panel that goes on the drive. I've known that this is not watertight for a while, but I wasn't sure why. So let me just see something here. This is not working worth a darn. Oh, maybe it is. Maybe they're just really, really tiny. This is really interesting, you guys. I've known that this is a problem, but I didn't know why. Okay, so there are two They're two just really flat. Ah, yeah, there they are. You can see them. They're two just really flat pieces in there. I wonder... I wonder if this can just be... I wonder if this just needs a reprocessing. Because it looks like... Oh! That's what's going on. I'm just being dumb. Yeah, so I'm building this mesh that doesn't have proper connectivity. So I'm adding detail to this chunk, but I'm bumping, you see that? I'm bumping up these vertices right against an edge. So, yeah. That's not gonna fly. Let's diagnose this quick. Or figure out just where that is, and then disable it, because I don't really like how those look anyway. And let's see here. Agreeable, yeah. Yeah, this nonsense. That's not allowed. What am I even doing here? So I'm raising it. Just need to not do that. We'll figure out a better. This all runs so much faster now with manifold for booleans, it's crazy. Yeah, see, we're missing those details now, which is what I want. Oh, that's awesome. Look at that. My shroud actually works properly in high detail. Oh, that's so cool. We got a little bit of a little bit of detail coming through there, but oh, that's so cool that that worked. Okay, let's go back to our printing bench now, and I bet we won't have this watertight problem anymore. Or if we do, it'll be on something else. Okay, yeah. Yep, now this one isn't watertight. And the reason that this one isn't watertight is because it's not one manifold, it's a bunch already. So this one is actually going to be a lot easier to deal with. Yep, and then these windows, those can be easily tossed out. The markings can be easily tossed out. This guy is another instance of something that should be able to be separated into a bunch of watertight components, I think. Except for maybe some edge loops. Okay, cool. So that's looking like it's in pretty good shape. I got my watertight check running and got some insights into what's going on. So I need to quit and start my day job now, but thanks to everybody who watched. Thanks to LuxCore and Jersey for stopping by. Good to see you guys, and I hope you guys have a good rest of your day. Bye.